Today we're dismantling some of the most persistent myths in all of human history, the ones surrounding how the Great Pyramid of Giza was actually built. Because right now, in 2026, we are raising carbon-neutral skyscrapers using GPS satellites, laser leveling, and digital project management platforms. And yet the veteran site directors who oversee billion-dollar construction projects, the best in the world at what they do, consistently report the same thing when they study Giza up close. The tolerances are better than what they routinely achieve today. The base of the Great Pyramid is leveled to within 2.1 centimeters across a 230-meter footprint. That is a margin of error of 0.009%. The Burj Khalifa, the tallest building on Earth, was built with every modern tool imaginable, and its tolerances are comparable, not clearly superior. That single fact should stop anyone who calls this structure primitive dead in their tracks. So let's get into it. Here's where the myths come from. Almost everything the ancient world believed about Giza, and everything that got repeated through textbooks for generations, traces back to one source, the Greek historian Herodotus. The problem? Herodotus wrote about the pyramids roughly 2,000 years after they were built. He is, essentially, the ancient world's internet rumor. And the biggest rumor he spread was this: slaves built the pyramids. This is false. Archaeology has buried it completely. Excavations at Giza's worker village reveal a paid, organized, and medically supported labor force of approximately 20,000 to 30,000 skilled workers. These were not slaves in chains. They were specialists with names. They had tombs built in their honor. Their skeletons show healed bone fractures, evidence of actual medical treatment. They organized into crews called phyle, and those crews gave themselves names that were literally carved into the pyramid blocks themselves. Friends of Khufu and Drunkards of Menkaure. And in 2013, archaeologists discovered the Papyrus of Merer, a real, datable supervisor's logbook from approximately 2565 BCE, documenting his team's daily delivery of Tura limestone to Giza by boat along the Nile. It is the world's oldest operational management record. This is not mythology. This is project documentation. Now let's talk about scale, because this is where even experienced engineers stop and recalibrate. Moving 2.3 million stone blocks to complete the pyramid in 20 years required placing an average of 315 blocks every single day. Over a 10-hour working day, that is roughly one block placed every 2 minutes, for 20 years. Each of those blocks weighed between 2 and 15 tons for the core limestone, with some interior granite blocks exceeding 60 tons. Casing stones came from Tura, across the Nile, transported by barge during the annual flood season. Granite for the interior chambers came from Aswan, over 800 kilometers south. Modern project managers have a name for what the Egyptians were running: a just-in-time supply chain, where materials arrive precisely when needed to minimize staging and waste. The ancient Egyptians were operating this at a scale that no pre-digital civilization has come close to matching. But here's what's even more counterintuitive: the precision at the micro level. Surviving casing stones on the Great Pyramid fit together so tightly that a razor blade cannot pass between them. We're talking tolerances of 0.5 millimeters on stones weighing multiple tons. The myth says this required lost technology or something supernatural. The reality is actually more impressive. Here is the physics. Copper has a hardness rating of about 3 on the Mohs scale. Granite sits at 6 to 7. By pure logic, copper should be physically incapable of cutting granite. And it was. The copper was never the cutter. The quartz sand packed between the tool and the stone was the cutting agent. Quartz scores a 7 on that same scale. The copper was merely the carrier. This is identical physics to modern water jet cutting, where pressurized water carries abrasive particles to do the actual work. Workers also exploited thermal expansion, heating stone surfaces and applying cold water to create controlled microfractures. The result? Millimeter-level accuracy, achieved with materials available in the Bronze Age. Time-intensive, yes. Impossible? Absolutely not. The ramp theory, though, that one actually collapses under its own logic. The most commonly taught explanation for how blocks were raised is that workers built a massive earthen ramp alongside the pyramid as it grew. Run the numbers on that. A straight external ramp reaching the pyramid's 146-meter apex at a safe 8-degree grade would need to stretch over 1.5 kilometers in length. The total volume of material required for that ramp would exceed the total volume of the pyramid itself. You would have needed to build 2 pyramids just to build one. In 2003, French architect Jean-Pierre proposed a far more elegant solution, backed by 3D modeling. A corkscrew internal ramp, approximately 6 feet wide, spiraling upward inside the pyramid as construction progressed. A 2026 study published in Nature added another layer, proposing that the Grand Gallery itself functioned as a counterweight pulley system to assist block elevation. The current best hypothesis combines both: external ramps for the lower third, internal systems for the rest. And then there is the final challenge, the last 10%. As the pyramid rises toward its apex, the working platform shrinks from the size of several football fields down to the size of a kitchen. Every logistical system that worked at ground level breaks down. The weight-bearing physics of the upper courses would exceed the safe operating limits of many modern cranes. And at the very top, the pyramidion, the gilded capstone, likely coated in electrum, had to be placed with the same millimeter-level precision as every stone beneath it, from a platform you couldn't fit a dining table on. The psychological and logistical pressure of that single moment, what engineers today call the capstone moment, was the culmination of 2 decades of supply chain management, tool engineering, and human coordination. What emerges from serious analysis is not a mystery of lost technology. It is something far more extraordinary, a triumph of management science, operating 4,500 years before the spreadsheet. Veteran site directors who have spent 30 years running billion-dollar builds arrive at the same conclusion. If you strip their firms of all digital infrastructure tomorrow, they could not replicate what happened at Giza. And this is not lost on the space industry. NASA and ESA teams studying lunar and Martian construction faced the same core challenge the Giza builders solved: large-scale construction with communication delays, zero digital tools, and severe resource constraints. Giza's hierarchical crew model, modular workflow, and pre-positioned supply chains are being actively studied as templates for building off-world. The Great Pyramid is not just the world's oldest proof of organizational genius. It may also be the blueprint for our future. If there is a myth about Giza you want us to dig into next, drop it in the comments below. And if this changed how you think about ancient engineering, share it, because this is exactly the kind of history that deserves a much bigger audience.